Okay, welcome to this Paper 2 Foundation video. Now, I did go over some of this at the start of the Paper 1, so I'm not going to spend too long talking through this part. But if you go into the description, you'll see that at the top there you can download the booklet to go along with this. You may just want to use the video, but at any point you can go in and download the booklet. As well as that, you've got the links to Paper 1 and Paper 2 and Paper 3. So you can go through those and make sure that you access all of these videos. You've got some links to some of my resources you can download from the website, and if you keep scrolling down you have video links next to every topic in the video that allows you to go more in depth into any topic as you go. Now, very quickly before we get started, again I'm just going to very quickly show you all of the topics that are included using my checklist, and you'll see that there's then not going to be many topics left for Paper 3. So let's just have a look at that one now. So what I've done is I've highlighted or ticked all of the boxes here that we go over in this paper in the purple pen. So you can see the red pen there shows the topics that we went over in Paper 1, and the purple is showing the topics on Paper 2. So you see we go through quite a few topics on number algebra and some in the trigonometry section there. We've got some Pythagoras Theorem, and then also into our statistics, ratio, geometry and probability we have a large majority of everything from the paper. So you can see that we are slowly getting through all of this list, and we will cover the large majority of what's left in Paper 3. But there you go, feel free to download this checklist, the link is at the top of the description, but without further ado, let's get started. So we are looking at the foundations here, and we're looking at Paper 2, so you're going to need your calculator for this, and not to forget, if you've got the booklet printed off, you can scan the QR code at any point and it'll bring you back to this video. So looking at question 1, we've got write 7,829 to the nearest 1,000. Well, as we're rounding that to the nearest 1,000, that'll have to go up to 8,000. There we go, there is our question 1. For the next one, we are writing down the name of this 3D shape. Now, this particular 3D shape here is called a cuboid, but of course there are lots of different 3D shapes that you could be asked. You could have a sphere, you could have a cylinder, or any other 3D shape like a cone, etc. And you're going to need to know the name of all those 3D shapes, but hopefully just a nice, easy 1-mark question there for our first page. Shading in 3/4 of this shape. Well, let's just have a look. So that means for every 4 squares we need to shade in 3. And if you have a look, it goes 4 squares across. So on the top row, if I shaded in 3 of those 4, and let's continue that pattern down. So 3 out of 4 on the second, and 3 out of 4 on that final one there. And there you go, that's 3/4 shaded. You should have 3 squares that we've not got shaded there. Right, 0.07 as a percentage. Well, that place value of the first decimal place is the tens when it's a percentage, so this is just our units here in terms of an actual percentage. That is just 7% in that hundredths column. You can always multiply a decimal by 100, so if you wanted to imagine this, you've got 0.07 multiplied by 100, the decimal jumps over twice and it becomes 7%. And there you go, there is converting a decimal to a percentage. Question 5, here is a list of numbers. From the numbers in the list, write down a cube number. I've emphasised a cube number there because we just want to write down one number that is a cube number. So we don't want to write down multiple if there are more than one. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. That's in the list there. So we could just write down 27. And there we go, absolutely fine. But let's just check to see if there's another one. 4 times 4 is 16. Times 4 again is 64. So you could actually have written down 64 as well. Both of those are cube numbers. But there we go, we've just gone for a cube number, and I've gone for 27. On to the next one. Toyab, Caden and Luke are going to play a game. At the end of the game, one of them will win, or one of them will be in first place, one of them will be in second place, and one of them will be in third place. Use the table below to list all the possible outcomes of the game. So I'm just going to put their first initials in position and just show some of the outcomes to start with. So if we just put them in the order that they've said the names, so if we have Toyab, Caden and Luke, and then let's imagine Toyab still wins, but Caden and Luke swap positions. Now that's all the pattern that we can have if Toyab is in first place. But if we put someone else into first place, so let's say Caden wins, and this time Toyab comes second and Luke comes last, then we've got another scenario where Caden wins, Luke comes second, and Toyab's last. So we've got 4 outcomes so far. We haven't had Luke in first place yet, so let's put Luke in first place, Toyab second, and Caden last. And then Luke's still winning, but we've got Caden second and Toyab last. So you see the logical approach that I took there by starting with the same winner for 2 options while we swapped it over, and then obviously just followed that pattern with everyone being in that first place position. And there we go, we've listed all the possible outcomes of the game there. On to the next question. So question 7, Olivia makes hats. She makes at least 17 hats per hour, and she's paid 46p for each hat that she makes. Anwar is a waiter. He works 35 hours and is paid a total of £266. Show that Olivia's hourly rate of pay is more than Anwar's hourly rate of pay. So Olivia's hourly rate of pay will depend on how many hats she makes, and it says she makes at least 17 per hour, and she's paid 46p for each hat. So over the course of that hour, she will be paid 17 lots of 46p. So 17 multiplied by 46. Now this is a calculator paper, so I'm not going to do any column multiplication. I'm just going to type that into my calculator. 17 times 46 is 782 pence. I'm going to convert that into pounds as well, just in case our other one's in pounds. So if we divide that by 100, that is £7.82 per hour, and that's for Olivia. If we move on to Anwar, Anwar works for 35 hours and he's paid £266. So if we divide that by the 35 hours, so £266 divided by 35, again just typing that into my calculator, and that gives me £7.60. So it came out on the calculator as 7.6, which is £7.60 in terms of money. So there's Anwar's, he gets £7.60 and Olivia gets £7.82. So show that Olivia's hourly rate of pay. I just want to make this really obvious. I'm just going to point an arrow there and just say Olivia is paid more. Just labelling the fact that I know what I'm talking about. I don't need to write there how much more that she's paid. Of course, it's fine for you to do that, but if you are going to do that, just make sure you get it right. So £7.82, take away £7.60, do that on your calculator. The last thing you want to do at this point is write that, say, Olivia's paid 12 pence more, because she's not paid 12 pence more, she's paid 22 pence more. So we don't want to lose a mark by writing an incorrect conclusion, but it doesn't ask us. It doesn't say show how much more Olivia's paid, it just says show that she's paid more. So there we go, Olivia is paid more. And there we go, we get full marks for that. On to question 8. 65% of the students at a school walk to school. Work out the percentage of students who do not walk to school. Well, the total percentage has to be 100, so it'll be 100. Take away this 65%, and that's a total of 35. So that'd be 35% that do not walk to school. It says what fraction of the students walk to school. Well, we know 65% walk to school. That's 65% out of the total 100%. So that'd be 65 over 100. It doesn't say to give your answer in its simplest form, so I'm not going to bother simplifying it. Again, I don't want to make a mistake, but you do have a calculator. So if I just press my fraction button, or I can type in 65 divided by 100, and that will simplify it for me, and I get 13 over 20 on my calculator. Either answer is fine, so you could give a simplified version, but you don't need to. It doesn't say give your answer in its simplest form. So there we go, 65 over 100, absolutely fine for that 1 mark. Okay, so this one, you can use this graph to change between stones and kilograms. And if we look at the graph, we've got kilograms going up the y-axis, we have stones going along the x-axis. And part A here says change 3 stone into kilograms. So looking at our stones here on our x-axis, and here is our 3 stone. So if we go up to the graph, and we use a ruler and a pencil for this, and then we're going to trace that along absolutely perfectly to the y-axis. Now that is 1 square below 20. So I need to have a look at my scale there, and if I zoom in, you can see that there are 10 squares between 10 and 20. So going up to this halfway point, that would be 15. So 1 square below 20 would have to be 19. So that's going to be 19. You just need to be very careful there that you do look at your scale, make sure you get that right. So that's 19 kilograms for that part. For part B, it says change 80 kilograms into stones. Now if we go back to our table, look, you can see it only goes up to, and to be fair, it only goes up to 60, and it looks like 63 and a bit there that it goes up to if you look right at the end here. So we're not going to be able to get it straight from the graph. We're going to have to think about how we can create 80 kilograms using some of the kilograms that we have. Now the easiest way I can think of is if we go for 40, turn that into stone and then double it. But of course you could work out 10 kilograms in stone, and you could times that by 8 or any other combination that you can think of. But I quite like going for the biggest number possible to get it as accurate as we can, and then I'll just double that number, which is nice and easy to do. That looks like it's going down between a square, so I'm going to have to be very careful here. Much easier with a ruler and a pencil. And there we go. Now you are going to be allowed some error on this one. Doesn't have to be absolutely perfect, but you do need to get it as perfect as you can. So that's going between 6 and 7, so that'd be 6.2, 6.4, 6.6, 6.8 and then 7 there. So that is somewhere between 6.2 and 6.4, so let's say that is 6.3. And that's me just trying to be as accurate as I possibly can, but of course you might get 6.2 or 6.4 and that'd be absolutely fine. So bearing in mind that was 40 kilograms and we wanted 80 kilograms, I just need to times that by 2. So we'd have 6.3 stone for my working out multiplied by 2, and that's going to give me 12.6. So we go 12.6 stone would be my final answer, and as I said, you are allowed a little bit of leeway either side of the number there. And of course, if you went for 10 kilograms, it might not be as accurate and you'd have to scale it up. To be fair, if we have a look and see what we'd have got, if we'd have gone for 10 kilograms, it might be that it gives us a different number. So if we go down from there, that's 1.246. So that would have been 1.6, and we'd multiply that one by 8. If I do that on the calculator, 1.6 times 8 gives you 12.8. So there you go, that's 0.2 bigger than my answer, and that'll be absolutely fine. So any of those answers would be fine, just depends on where you read it from your graph and what exact number you get there. But there we go, there is our answer for part B. On to question 10. So the length of a car is 3.6 metres. Jaya makes a scale model of the car and she uses a scale of 1 centimetre to 30 centimetres. So in other words, her model is going to be 30 times smaller than the real thing. Work out the length of the scale model of the car and give your answer in centimetres. Now, as it says it's going to be in centimetres, we're definitely going to want to convert this 3.6 metres into centimetres. There's 100 centimetres in every metre, so multiplying that by 100 would give you 360 centimetres. Now that it's in centimetres, we can use this conversion here. 1 centimetre is 30 centimetres. So our model is going to be 30 times smaller. So I want to do 360 divided by 30 to make sure that it does get 30 times smaller. Again, we could probably do that without a calculator. I'm going to type it in just as good practice because it's a calculator paper, and that comes out as 12. So the scale model will be 12 centimetres long. We just want to put that as our final answer, 12. And there you go. Obviously, if we'd have been given the length of the scale model, been asked to write the length of the actual car, then we would have multiplied by 30 with that particular ratio there, 1 to 30. Okay, on to question 11. Abigail is watching a film at the cinema. The film started at 2:30 and the film is 105 minutes long. When the film ends, she takes 20 minutes to get to the bus stop and the bus leaves at 4:45. Does Abigail get to the bus stop in time to get this bus? And you must show all your working. So really important there, you must show all your working. So let's do every step. So the film starts at 2:30 and it's 105 minutes long. There's 60 minutes in an hour. So that would be 60 minutes, and to get to 105, that would be another 45 minutes. So if we add the 60 minutes on first, 2:30 would go to, well, 14:30 as they've written it, would go to 15:30. Then add the 45, that would get us to 4 o'clock, and then past it, because we've got the 30 minutes to get to 4 o'clock, so that would get to 16:15 or 4:15. So the film is going to end at 4:15. It says then when the film ends, Abigail takes 20 minutes to get to the bus stop. So we're currently sitting at 4:15, and it's going to be another 20 minutes. So if we add 20 minutes to that, it would become 16:35. And there we go, that would be the time when she gets to the bus stop. So it says here the bus leaves at 16:45. Does Abigail get to the bus stop in time? So yes, because Abigail arrives at 16:35. So yes, Abigail arrives at 16:35. So she is definitely going to get there in time. There we go, we've shown all our working because we've shown those steps there of how we actually manipulated the time to figure out when she'd arrive. On to question 12. Okay, so question 12 says WXYZ is a quadrilateral and XYV is a straight line. So XYV is this line here. It says find the size of angle marked A, which is marked on the diagram. Now we know that angles next to one another on a straight line add up to 180. So to find angle A, we would do 180, take away 147. Again, we've got a calculator, so let's type it in, even though that's not overly difficult to do, but that gives us the answer 33 degrees. So our answer for that, 33 degrees, and again, just make sure you keep using your calculator on these questions. It says give a reason for your answer to part A. That we've already mentioned, because by writing down 180 take away 147, we knew that therefore angles on a straight line add up to 180 degrees. So angles on a straight line add up to 180 degrees. And there we go, there is our reason, full marks for that. It then says angle ZWX is equal to WXY. So ZWX is this one here, and WXY is this one just here. So we know that they're the same, we already know that this one is 33. So this is testing our knowledge of angles in a quadrilateral, as it says work out the size of angle ZWX. Now they're both the same, so it doesn't really matter which one we work out of the two, but we're going to look at this quadrilateral just here. Now angles in a quadrilateral add up to 360 degrees. So if we take that 145 and that 33 and add them together, so 145 plus the 33, again using the calculator, plus 33, and that is 178. So that currently adds up to 178. If we take that away from the total, 360, that will tell us what's left to share between those two angles, and that is 182 degrees. Now, as it says that those two angles are equal, we know that they are the same size. So all we need to do is take what we have left, 182, and divide that by 2. Again, I'm doing this all on the calculator. That comes out as 91 degrees. So there we go, 91 degrees is the size of the angle. It doesn't matter which one we pick there because they're both the same, even though it's asking for ZWX. And there we go. Question 13 is looking at a stem and leaf diagram. So it says it shows the information about the heights in centimetres of the boys in a class. And it says over here in the key that 15-1 is 151 centimetres. So it says find the median height. To find the median, we want to know where the middle is. So we're going to cross off some numbers from the start of the stem and leaf. I'm going to go for 5 of them, and then cross off some numbers from the end of the stem and leaf. Again, we've got to do the same amount for 5, and see there how I'm working backwards from the end of the list. Let's do another 3 from the start. So 1, 2, 3, 1, 2, 3, and I'm just going to do one at a time. So 1 and 1, 1 and 1, and then we're left with the middle just there. So that middle number, that 5, not forgetting the key, 16 is at the start of that row, so it's 16 line 5, which is 165 centimetres. And there we go, there's our final answer for the median. Then it says find the range of the heights. And this is where you've got to be careful. You don't want to scribble out these numbers too much, because we now want to actually read from the stem and leaf again. The range is the biggest, take away the smallest. So our biggest number is this one here, which would represent 181. And our smallest is this number here, which is 140. So 181 take away 140 leaves us with 41. Again, I'm just going to type that into my calculator though, 181, take away 140, confirm my answer, and there we go, 41 centimetres is the range of the heights, the distance between the biggest and smallest. On to question 14. An exam has two papers, paper 1 and paper 2. Paper 1 has 60 marks, paper 2 has 90 marks, and the pass mark is 2/3 of the total number of marks. Gia gets 70% of the marks for paper 1. How many marks for paper 2 must Gia get in order to get the pass mark? So the pass is 2/3 of the total, and the total of these two is going to be 150 marks. 60 plus 90. So we want to work out what 2/3 of that is. So 2/3 of 150. To do that, we first find 1/3, which is just dividing by 3. So 1/3 is going to be 50 marks. 2/3 is going to be double that. So 2/3 is going to be 100 marks. So the pass is in order to pass, you're going to need 100 marks. It says that Gia gets 70% on the marks for paper 1. So we need to work out 70% of the paper 1. And there's 60 marks on paper 1. So let's work out 70% of 60. That's going to tell us how many marks she got on paper 1. So to do that, we'll find 10%. There are quick tricks on the calculator, but we're not going to apply any quick tricks. We're going to show all our working out to make sure we pick up as many marks as possible. 10% of 60 is 6. And then we want 7 of those, so 6 times 7, which we don't really need to type in on the calculator, but I get into the habit of using my calculator for everything on a calculator paper. 70% would be 42 marks. So that's what she's got on paper 1. She needs to get 100 marks in total. So the 100 marks she needs to get to pass, if we take away the 42 marks that she's got on paper 1, 100 take away 42 on the calculator again is 58 marks. So can she do that? Because paper 2 is at 90 marks, so yes, she's going to be able to do it, but she only asks us how many marks she needs. That answer is 58. And there we go, there's our final answer for that, working out fraction of an amount and a percentage of an amount. On to question 15. Ryan makes a drink by mixing 1 part of orange squash with 9 parts water. He uses 750 millilitres of orange squash. Ryan is going to put the drinks he makes into 1 litre bottles. Work out the greatest number of 1 litre bottles that Ryan can completely fill. Well, we could write this as a ratio. There's probably different ways we could approach this, but 1 to 9. He's going to use 750 millilitres of the squash. So this is the orange squash, this is the water. The 1 is turning into 750 millilitres. To get there, we have to times by 750. So if we do the same to the other side, that'll tell us how much water he needs. Definitely on the calculator, 9 times 750 comes out as 6,750. And if we add those both together, that's going to tell us the total. So add 750 to that, and we get 7,500 millilitres. So that's how much drink that he actually has. He's only going to put it into 1 litre bottles though. We want to know how many he can completely fill. Now 1 litre is equal to 1,000 millilitres. So if we divide that by 1,000, we get 7.5 bottles. Now we can't fill up the 8th bottle. We can fill up 7 and then one of them is going to be half full, and it does say how many can he completely fill. So we're going to have to round that down. That'll be 7 bottles that he can completely fill, but of course he's going to have half a bottle left over. So there we go, there's our answer for that one. On to question 16. Kai works in a cafe. At 11 AM one day, he records the number of customers sitting at each table in the cafe, and here are his results. So on the left, we've got the number of customers sitting at a table and the number of tables with that many customers. So you can see there, 4 tables had 0 customers, and so on down the table. Write the modal number of customers sitting at a table. So modal is just the mode, and the mode is the most common. So if we're finding the mode, well, the most common is this one here. It happens 10 times, and that is referring to 2 customers. So the mode is not the 10, it's the 2 customers. So it says the modal number of customers. So 2. And that is the most common number of customers sat in the tables. It then says work out the mean number of customers. So when working out the mean, we do have a little bit more working out to do. We have to find the total of each row. So there are 4 tables with 0 customers. 0 times 4 is 0. There are 5 tables with 1 customer. 1 times 5 is 5. And we can just carry that along. So 2 times 10 is 20. 3 times 7, 21. 4 times 3, total of 12 customers. And 5 times 1 is a total of 5 customers. If we add those all up, so 0 plus 5 plus 20 plus 21 plus 12 plus 5, that is a total of 63 customers. We then want to divide by how many tables there are. So if we count up the number of tables here, we have 4 plus 5, which is 9, plus 10, plus 7, plus 3 plus 1. And that equals 30. Always check, it might have told you that in the question. It doesn't actually say. So there we go, we've found it from the table anyway. So to work out the mean, the total number of customers is 63. And there are 30 tables. So 63 divided by 30. Let's see what we get. We get 2.1. So our final answer is 2.1, and 2.1 is our mean. There we go, so there is working out the mode from a table and also working out the mean. On to question 17. Evie goes on holiday to South Africa. Evie wants to change £850 into South African rand. She wants to get as many 200 rand notes as possible, and the exchange rate is £1 to 18.53 rand. Work out the greatest number of 200 rand notes that Evie can get for her £850. So to convert £850 into rand, just have a look at this and think a bit logically. So the actual amount of rand is a higher number than the amount of pounds. And again, you can think about it as a ratio. But we are going from £1 to 18.53 rand. So to get from £850, we'd have to do the same thing, which is multiplying by 18.53. So if we multiply by 18.53, again definitely doing this on the calculator, 850 multiplied by 18.53, and here we go, we get 15750.5, this is money, so 0.50, 15,750.50 rand. Now we have a similar process to one of our previous questions. We want to know how many 200 rand notes that Evie can get. So we want to divide this by 200, and that'll tell us how many notes she can get. So if I just press divide by 200 on my calculator, I do get a decimal. I get 78.7525. So in terms of how many notes she can get 78 notes, but she's going to have some left over there, so she would get some of her pounds back, and she would get a certain amount of 200 rand notes. So 78 notes. It doesn't ask us how much that's worth, but you could do just 78 multiplied by 200, and there you go, she gets 15,600 rand. So she can't actually buy the full amount that she can afford. She can afford 15,750.50, but actually she's only going to get 15,600 as she can only buy 200 rand notes. On to question 18. Expand and simplify a double bracket. So I'm going to do the x times the x, which is x squared, the x times the negative 9, negative 9x, and then move on to the 5. 5 times x is plus 5x. 5 times negative 9, negative 45. I then need to do my simplification. So I'm going to simplify these middle two. I get the x squared at the start, negative 9 add 5, and again, that's negative 4, but you can type it in your calculator, negative 9 add 5, just to confirm, minus 4x and minus 45. It's worth typing it in because you're always sort of sitting in an exam, you're a little bit worried and you're trying to rush through some questions, just double check them, get them right, and then you can move past this question knowing that you've got it perfect. So there's our final answer, x squared minus 4x minus 45. The next one we've got factorise fully. we have 9x squared y plus 6xy squared. So when we have factorised fully, it means more than one thing's going to come out of the bracket. So I'm going to first look at the numbers. 9 and 6, they both divide by 3. So 3 can go on the outside of the bracket. They both have an x to the power of 1, at least in. Our first piece there has an x squared, but this other one doesn't, so we can take an x out. The first one has a y, the other one has a y squared, so again we can take a y out, and then I want to open up the bracket. Again, I'm doing this to the side here so I can check that I don't make any mistakes before I draw it on the dotted line. So to get from 3 to 9, we'd have to multiply by 3, and to turn that x into an x squared, we're going to need another x. Then we've got our plus sign. To get 3 to a 6, we're going to have to multiply by 2. We've already got an x, but we want to get the y to a y squared, so I want to stick a y with that. And that's factorised fully, so now we can write that on the dotted line. 3xy brackets 3x plus 2y, and it's always a good point in the question to expand that and just double check that you've got it right. But there we go, there's factorising. Okay, so we've got a transformation. Describe fully the single transformation that maps triangle C onto triangle D. So that's going from there to there. Well, you can see the shape has not been reflected, it's not been rotated, and it's not changed size, so this must be a translation. So pick a coordinate. I'm going to pick the top left. How do we move it to there? Well, we do that by using a vector. Now you can either check the up and down first. I know it goes up by 2 to get to this point, and it goes across by 1, 2, 3, 4. So there we go, it goes 4 across and 2 up. When you're drawing a vector, the number on the top is the right and left, so to the right is positive 4 and up is positive 2. So that's the vector that the triangle moves in. To describe that, I need to write that it's a translation. So I'm going to say a translation by the vector, and then write that vector. So it was 4 on the top, 2 on the bottom, and that matches, so I'm happy with that. So it's a translation by the vector 4, 2. Okay, on to question 20. Work out the reciprocal of 0.125. Now the reciprocal is when we flip a fraction over, but at the moment that's a decimal. If I type 0.125 into my calculator and press equals, it does actually bring up what this fraction is, and that fraction is 1 over 8. So that's not too bad. Now I can flip it over and it becomes 8 over 1, and you don't need to write that as a fraction with 1 on the bottom, so the reciprocal is just 8. And there we go, there is writing the reciprocal. For the next one, we've got writing this fraction as a power of 3. We've got quite a lot of powers there in terms of the size of that power, but don't let that throw you off. We know that when we're multiplying, we add the powers. So on the top, we've got a power of 140 and a power of 59. I'm going to type it into my calculator. So 140 plus 59 is 199. So that's 3 to the power of 199. On the bottom, we have 3 to the power of 49. We know that when we are dividing with the same base number, which we have in all of these, we subtract the powers. So 199 on the calculator, take away 49, leaves us with 150. So that is 3 to the power of 150. It says to leave your answer as a power of 3, so I just need to write that as 3 to the power of 150. And there you go, final answer. For part C, we have some brackets involved. We know that when powers are in brackets, you multiply them. So you've got y times 3 is equal to 60. You could write that as an equation if you want. You could write 3y has to equal 60. As we know, those powers are going to multiply to make 60. So dividing by 3, you know that y has to equal 20. And you can write that down there, or you might have actually just spotted that it's going to have to be 20. But there you go, the value of y is 20. Okay, on to question 21, and we have a Venn diagram. So it says here all the numbers in the set are 1 to 13, and just count them, make sure there's none missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, so it's all the numbers there. A is multiples of 3 and B is the even numbers. Complete the Venn diagram. I'm going to start by labelling this A and B to start with. Then I'm going to write next to where it says multiples of 3, all the multiples of 3 in this actual list. So we have 3 6, 9 and 12. It doesn't go up to 15. And then the even numbers. So we've got 2, 4, I'm going to go up to 12. So 6, 8, 10, 12. So first of all, I'm going to find what numbers are in the intersection. So I have a 6 there, and I have a 12 there. So that means 6 and 12 are going to go in the middle. So they are the even numbers that are also multiples of 3. I'm going to cross those off my main list. So 6 and 12 is gone. I've then got 3 and 9 left in the A section. So I'll cross off 3 and cross off 9. I have 2, 4, 8 and 10 in the other one. So 2, 4, 8 and 10, and cross them off my main list. So 2, 4, 8, 10. And then the numbers that I have left, we've got 1, 5, 7, 11 and 13, and I need to put them on the outside. So 1, 5, 7, 11 and 13. And there we go, we don't have any questions there asking anything about the Venn diagram, but of course you could be asked something about the numbers in the intersection or the numbers in the union, so you do need to know your set theory as well. On to question 22. A supplier sells packets of sweets to shop owners. On Monday, 3 shop owners buy sweets from the supplier. Each shop owner buys small packets, medium packets and large packets of sweets. And then we've got some information. So Shania buys 400 packets of sweets, and we've got 32% are small and 40% are large, and that's our first bit of information. Stacey buys 500 packets of sweets, 3/10 are small, 1/10 are large. That's our second shop owner. And then our final one here, we've got Ruxton buys 150 small packets of sweets, so that the number of small to the number of medium packets is 3 to 4. Work out the total number of medium packets of sweets these shop owners buy, and you must show your working. Well, let's go back to that first shop owner. So Shania buys 400 packets, 32% are small packets. So if we want to work this out, and we're bearing in mind we've got our calculator, to get any percentage we can just divide by 100 and multiply by that percentage. So for this one here, 1%, if we divide by 100, of 400 packets is 4 sweets. So 32 multiplied by that would give us, let's just write this next to this, 128 packets of sweets. For the large packets, we have 4 times 40, and that gives us 160 packets of sweets for that one. Now that gives us the total amount of small and large packets of sweets, and that is a total of 288. So if they buy 400 packets of sweets in total, we could do a 400 take away the 288, and that would leave us with 112 packets of medium sweets. 400 minus 288, let's just double check, 112. Obviously you could do that slightly differently. You could add together 32% and 40% and work out the percentage that are medium and just work it out like that as well. But let's move on to Stacey. So Stacey buys 500 packets of sweets, 3/10 are small, 1/10 are large. So to work out 1/10, you divide by 10. So we could work out this 1/10 straight away. 500 divided by 10 is 50. So that would be 50 packets of large sweets. That's right over here, 1/10 is equal to 50. And that allows us also to get 3/10 because we just want to multiply that by 3. So 50 times 3 is 150. Again, in total, that means she's bought 200 packets of small and large sweets. And again, we could do 500, take away the small and large, and that leaves us with 300 medium packets of sweets. So we know that Shania bought 112 packets and Stacey bought 300 packets, and they are the medium sweets at the moment. We're then going to move on to Ruxton. So Ruxton buys 150 small packets, so that the number of small to the number of medium is 3 to 4. So a little bit of a different scenario here because we have small to medium, and that is 3 to 4. So we've got a slightly different form of ratio here because we are told that the small packets, or underneath the 3 here, is 150. And how do we get from 3 to 150? Well, on the calculator, 150 divided by 3 is 50. So we must have multiplied this ratio by 50. And if we do that to the other side, that gives us 200 for the medium sweets. And there we go, we've got Ruxton's amount of medium sweets. So we've got 200 there for Ruxton. So to work out the total amount, we just need to add those three together. So we have 112 plus, remember it says to show you're working, so we do want to write this down, so plus 300 and plus the 200. And again, I'm not going to do column addition here because we've got a calculator. So 112 plus 300 plus 200 equals 612. So there we go, all that information, but really all we had to do was work out a percentage of an amount. And again, you could have combined those two and worked out the missing percentage and worked that out, which might have been a little bit quicker. You could have added these together, that's 4/10 in total, and just worked out 6/10 instead, which would have been 300 for that one. And there wasn't any sort of quick route around the ratio there, but we got the 200 in the end there. So that's 612 in total, so down here 612. I think it'd be fine to just write 612 there. It's just showed the total number of medium packets, so we don't need to write 612 medium packets. It did actually ask us just to work out the amount of medium packets. So not too difficult there if you know percentage of an amount, you know fraction of an amount, and you know your ratio problems relatively well. I think that ratio one there was probably the hardest, so it was probably quite nice that they gave us that as that third bit of information. But there we go, 5 marks for that question there. Question 23, we've got solving an inequality, and we've also got writing an inequality on a number line. So whenever we're solving an inequality, we just treat it like we would when we're solving an equation. So as long as you know that, then you'll know how to solve an inequality. And we have letters on both sides. When we have letters on both sides, we always want to subtract the smallest coefficient of that letter from both sides. And in that case, or in this case, that is the 11n. So we want to take away 11n's from both sides of our inequality. If we do that, we will get 3n on the left, 14 take away 11, and on the right, all of those 11n's are gone. We've just got positive 6, so just 6 there. We don't need to write the plus in front of it. So 3n is greater than 6. Our final step, we want the value of 1n, so we're going to divide by 3. And when we divide by 3 there, we get a nice whole number. We get n is greater than 2. So that'll be our final answer. So we'd write that on the dotted line. N has got to be greater than 2. And there we go, there's solving an inequality with unknowns on both sides. For part B, we have on the number line, show the set of values of x for which negative 2 is less than x plus 3, which is less than or equal to 4. Now when we've got this in the middle, and it's not just an x there, we have to solve this inequality before we draw it. We treat it just like the one above, except whatever we do in the middle, we have to do to both numbers left and right. So in order to make it x in the middle, we're going to have to take away the 3. If we take away 3 from the middle, we take away 3 from the left and from the right. The symbols will stay the same, so we can draw those in, but negative 2 take away 3 is negative 5, and 4 take away 3 is 1. So the inequality that we're going to draw here is going to be on negative 5, so a circle above negative 5, and a circle above 1. We want to join those up. You now just need to decide if you're going to colour in either of these circles, and the inequality on the right has extra ink on the inequality, so we put the extra ink here in the circle and colour that one in. You can shade it all the way in if you want, but there we go, that one should be coloured in and the other one's not. And there we go, there's drawing an inequality on a number line where we have to do some solving as well. On to question 24. In a sale, the normal price of a book is reduced by 35%. The sale price of the book is £5.59. Work out the normal price. So we've got a reverse percentage. I like to draw a bar model when I'm doing a reverse percentage. We've knocked off 35%. So what percentage is left? Well, on our calculator, 100 take away 35 leaves us with 65%. And when we want to work out the normal price of the book before the reduction, that means it wants us to find out the original 100%, which means we've been given one of either the 65% or the 35%. So we just need to read this line very carefully and figure out if that is the 65% or if that is the 35%. Well, it's been reduced by 35%. But it doesn't say it's been reduced by £5.59. It says the sale price is £5.59, so that is the 65%. So I'd just write down to start with 65% is equal to £5.59. Nice and easy when we have a calculator, because I can always break this back down to 1% by dividing by whatever percentage we've been given. In this case, we've been given 65. So I would divide by 65 and type that in, £5.59, divide by 65, and that gives me 0.086. So 1% is 0.086. We want the original 100%. To get 1% to 100%, you just multiply by 100. So the original 100% times that by 100 on your calculator, and that comes out as 8.6, which in terms of money is £8.60. So the original price of the book was £8.60, and of course if you were to work out 35% of that and take it off £8.60, we would get that £5.59. So there we go, there is a reverse percentage. You just need to remember to read that line very carefully so you know what percentage you've actually been given, and then with a calculator, divide by that percentage, multiply by 100. So I'll always get you down to 1% and then back to 100%. On to question 25, we've got here is a triangular prism. Work out the volume of the prism and give your answer to 3 significant figures. To get the volume of any prism, you have to work out the area of the cross-section, which in this case is a triangle, and then multiply that by the depth, which in this case is 18, or you might call that the length of the prism. In order to work out the area of this triangular cross-section, we need the base and the height. We've got the height, 7.2, but we've not got the base. Let's call that x. But we have got the length of that hypotenuse there, as this is a right-angled triangle. So if we think about just the right-angled triangle, we have the height, 7.2, the hypotenuse, 8.4. We want to work out this missing side. To do that, we're going to use Pythagoras Theorem. So we are finding a shorter side, so I'm going to square them both, 8.4 squared and 7.2 squared. As we're finding the shorter side, we're going to take them away from one another. Let's type that in on the calculator, so 8.4 squared, take away 7.2 squared. That leaves us with 18.72. The final step in Pythagoras is to square root your answer. So I'm just going to press square root answer, press equals, and then I get an answer here, and that comes out as 4.326661531. Now I know that it says give your answer to 3 significant figures, but I'm not going to round that number until the latest possible stage. I don't want to round this to 3 significant figures because that might affect my answer and I might just get a slight rounding error. So I'm going to leave that as the whole number. I'm going to put up here 4.326661531. Now it always seems a bit awkward to have to write that, but it's less awkward than having to lose a mark because you couldn't be bothered to write down a couple of numbers. So there we go, I'm going to leave that in as it is. Now I can go about working out the area of that triangle. So if we work out the area of the triangle, and I'll just do that down here, because we don't need a bit more space. We've got the height is 7.2, the base there 4.326661531. So to work out this area, I'm going to do the base times height and then divide that by 2. So 7.2 times 4.326661531. Let's just put that all over 2 as we're going to divide it by 2. That will give me the area of the triangle. I can type that in on relatively easy on my calculator because I still have that 4.32 number, so I'm just going to press times 7.2, press equals. I get 31.15 and then divide by 2, and that gives me an area of 15.57598151. So that's the area of the cross section. So I've had to use Pythagoras to get the base so that I could work out the area of the triangle, but I now have the area of the cross section. As we mentioned at the start, once you've got the area of the cross section, you just need to multiply it by the length that it's going through the shape, which in this case is 18. So I'm going to take that answer there, multiply it by 18, that'll give me the volume. I've still got that number on the calculator, so I'm just going to press times 18, press equals, and I get 280.36766672. So there is my volume. It says give your answer to 3 significant figures. So if I go to the third significant figure, which is 280, so just after the 0 there, we have a 3 after the line. 3 is not going to round the 0 up, so my final answer will be 280. This question does give you the units there on the dotted line, so I don't need to write centimetre cubed, but do obviously be mindful of the fact that if it doesn't give you that, you are going to have to write the units in as well, and that's potentially going to be another mark, so always check that you're putting the correct units in. But there we go, the volume of this triangular prism. We've got there, we did Pythagoras to work out the missing length, then worked out the area of the triangle and did our normal volume of a prism by timesing it by the length that the cross section goes through the shape. Okay, on to question 26. So we've got to complete this table for y equals x squared plus x minus 4. Now when we're doing this, there are tricks you can do on the calculator. You can use your table method if you know how to do that, but I'm just going to do this assuming that anyone can do this no matter what calculator you have. So for the first one, and I tend to normally start with a positive number, but let's start with a negative this time. So we need to do the negative 3 squared. Now notice I've put that in brackets. You've got to do that on your calculator because otherwise it's going to square the 3 and then put a negative with it. You'll get the answer negative 9. We know that negative 3 squared is positive 9. So I don't want it to do that. So I'm going to then add negative 3. I'm just going to always put the number in a bracket and then take away 4. So if I type that exactly as I've written it on the paper into my calculator, so add brackets negative 3, take away 4. That comes out as 2. So I'll just write that into my table. Then all I need to do is change the number in the bracket, so I can just use the left and right function on my calculator. You can type it in all again, but I just need to change this number now and there for the 0. And that's going to give me that next one. So I'm just going to go into my calculator, delete the negative 3 and put a 0, and then delete the other negative 3 with a 0, and we get the answer negative 4. So there we go, minus 4. You can start to see a pattern. If you look, you've got 2 negative 4s here, then you've got 2 negative 2s on either side of that, then we have a 2 here, so this should be a 2. Now we'll test that out. Let's just have a look. What number went there? That was a 2, wasn't it? There we go. Let's just get rid of all this highlighter. Try and not delete everything. There we go. So if we type it in, let's just swap those zeros in the brackets for 2s and press equals, and it does give us the positive 2 we were looking for. Obviously that only helps us to find one of the values here, but now we're going to need to replace the 2s for 3s for our final value in the table. Press equals again, and there we go. We get the answer 8. So that's how we go about doing that, and we've completed the table. We now need to draw it on the graph, and it says draw it from the values x is negative 3 to 3, and that's what we're given in the table there, x from negative 3 to 3. So we want to do this very carefully. Negative 3 as our x coordinate, 2 as our y coordinate, so negative 3, 2. Now straight away, this is an awkward graph to draw on. So from 0, the origin, up to 5, let's have a look, let's just make sure we've got the scale. So is it every 2 squares? That would be 1, 2, 3, 4 and then 5. So every 2 little squares up is 1 on this graph. So always check that first. So negative 3, 2 would be negative 3 up by 4 little squares. That gets us this one here. The next one, negative 2, negative 2. So negative 2, and then we're going to go down 4 little squares. So that's just there. And then negative 1, negative 4. Negative 1, that's going to be 2 little squares above negative 5. So negative 1, negative 4. Then we have 0, negative 4, so the same height but across at the 0, so that's there. And then we have a bit of a pattern, don't we, because we already had the negative 2 and the 2, so negative 2, 4 squares below the 1, 1, 2, 3, 4's there. Then we've got 4 squares above the 2, 1, 2, 3, 4. And the last one, we haven't got the pattern for that, so let's have a look. 3 and 8. So 3, and that's going to be 4 squares below the 10 in terms of its height. That's a really awkward one to find unless you have a ruler, because it's not quite clear where that 10 is. So instead of doing that, I'm going to count up from the 5, because that line's a little bit thicker. So 5's here, and then that'd be 6, 7, 8. So there is 8. And obviously just pay attention to how carefully I did that. I've not rushed it. I've made sure I've got those points in the correct place, because I do not want to be losing marks for plotting a coordinate. Now that I've drawn the graph, I want to join that up using a nice smooth curve. That's always a little bit awkward for me to do on the screen, but I'm going to try my best. You don't want to miss any coordinates. So let's go along here and then back up. Take your time with it. Do it with a pencil just in case you miss any so you can rub this out. And there we go, I'm happy with that. So there we go, there is actually drawing the graph. We also have a part C here. It says use the graph to estimate a solution to the equation. Now it does say where it equals 0, and when it equals 0 we're looking at the roots. We're looking along the x-axis along here. So if we look along the x-axis, you can see that there is a solution here and there is also a solution there. Now the solution on the left, that lands for me right in the middle of those two. So this number here is in between -2 and -3. It's on the slightly thicker line, so that'd be -2.5. If we go across to the other one, that for me, is it in the middle? Let's have a look. 1, 2, 3, 4, 5. It is just in the middle for me, so that's actually landed really nicely, and that is 1.5. Again, there is going to be an allowable amount that you can have because everyone's graph will be slightly different in terms of the curve, but it's going to be pretty close to those numbers. So for the solutions, I will just say -2.5 and 1.5. And there we go. I don't write those as coordinates, I just say what those solutions are. And there we go, that's the end of the paper. So we've gone through a lot of topics there. Hopefully you found that useful and helpful. Don't forget to check out all of the video links in the description and make sure you download this paper. And don't forget to subscribe for my future papers and future videos for the upcoming exams. But there we go. Hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.